Ocean Acidification, Climate Change Biology by Monet Beatty. For tens of millions of years, Earth's oceans have been able to maintain a relatively stable acidity level. However, as climate of Earth is changing, the chemical makeup of the ocean is also changing. How are marine invertebrates affected by ocean acidification? Well, what is ocean acidification? We have to figure this out in order to find the relationship between ocean acidification and invertebrates. Ocean acidification begins with CO2 emissions. Most CO2 is produced by burning fossil fuels for industrial and automotive purposes. There has been a significant increase of CO2 emissions due to human activity. Now, the oceans have helped the atmosphere tremendously by being the biggest absorber of CO2 on Earth, of which observing almost half of it. However, this has serious and severe consequences to our oceans. It's important to recognize pH as it relates to acidity. The pH scale is from 0 to 14. 0 being the most acidic and 14 being the most alkaline or basic. The pH scale is also logarithmic, meaning a drop from 10 to 9 is times 10, and a drop from 10 to 8 is times 100. So we're talking about significant amounts here. pH equals potential to make charged ions. Charged ions are very important in ocean acidification. Let's go back to introducing carbon dioxide to seawater. According to the California Academy of Sciences, during the industrial era in the years 1751 to early 1990s, the surface ocean pH decreased from 8.25 to 8.14. That doesn't sound like a lot, but we have to remember, this is a total average change on all oceans on the globe. And pH is also logarithmic, making the ocean 30% more acidic. This is because the concentration of hydrogen ions increased, causing a decrease in pH, making the ocean more acidic. So the CO2 in the atmosphere is absorbed by oceans. The H2O and CO2 cause a chemical reaction. CO2 plus H2O equals carbonic acid. Carbonic acid can be further broken down into bicarbonate and also carbonate ions. This process releases more hydrogen ions. The change in pH causes chemical reactions that reduce available carbonate ions. Many marine invertebrates are very dependent on calcium carbonate. When you add calcium ions to carbonate ions, you get calcium carbonate. But carbonate ions bond with more hydrogen ions, which result in more bicarbonate and less calcium carbonate. The following diagram shows the concentrations of carbonate ions in the Gulf of Mexico. As you can see, the concentrations are between 270 and 260 in the darker blue area. This is in the year 1990. This graph shows the concentrations of carbonate ions in the Gulf of Mexico in the year 2000. The concentrations are varying between 250 and 230. This diagram shows the concentrations in 2010, and you can definitely see the decrease in concentrations in the range 240 to 220. The concentration of carbonate ions is decreasing because they are bonding with a highly acidic hydrogen ion, meaning there is less calcium carbonate, the main structure used for the skeleton of marine invertebrates. Thank you for watching.